Hello everybody, welcome to GTek. This is the second video in a series of the repair and restoration of the Phase Linear 400 Series 1 power amplifier. In this episode, we'll be doing a modification, and we'll also be installing output transistors and driver transistors. If you like what you see in this video, hit the like button and subscribe. Well, let's get into it.
Warning: do not attempt this project unless you are experienced with electrical circuits. Serious injury, property damage, and even death can occur with this wire.
A new friend of mine asked if I had performed a C6 capacitor change and diode modification. Here we have C6, a 100 microfarad polarized capacitor located between the input differential stage and the next stage. Here is a modification. C6 is changed from 100 microfarad to 470 microfarad, and two 1N4148 diodes are added across it in back-to-back configuration. The 470 microfarad capacitor improves sub-base response, and the two back-to-back diodes resolve an issue where the amplifier has been known to latch up, possibly causing damage. At turn-on, the amplifier can develop an unbalanced voltage across these stages. These diodes clamp the voltage across C6 to a safe level and prevent that latch-up condition from occurring. Let's go ahead and remove both capacitors. Make sure to observe the polarity of each capacitor before removing it so the new capacitors can be installed correctly. Again, making sure the polarity is correct, we can go ahead and solder the new capacitors in place. Now we can trim the leads using flush cutters. I installed two diodes back to back by twisting the leads together, bending them 90 degrees, and placing them across C6 on the printed circuit side of the board. Now we can solder them in place. As you just saw, we performed the same modification on the other channel. To make sure we did not overheat or damage the diodes during soldering, let's check them with the meter. We have a .538 voltage drop in this polarity, so that is good. Now let's reverse the leads and check the opposite polarity. We should see about the same reading. And we do. We are good to go. If either diode has been damaged, we would likely see either a short or an open reading. After soldering, always make sure to clean the flux residue from the board. I'm using 90% isopropyl alcohol and a toothbrush, then wiping the area dry. Now let's move to the backplane and check the diodes. We'll start with D14. Positive probe on the cathode, negative probe on the anode. We have an open reading. Now reversing polarity, we have a .452 volt drop. This diode is good. Now let's take a look at D15. Again, positive probe on the cathode and negative on the anode, we have an open reading. Now reversing polarity, we have a .446 voltage drop. This diode is good. I also checked D14 and 15 on the other channel, and they are good as well. Now let's check the output emitter resistors. As the schematic shows, these are .22 ohm resistors. We need to make sure that they are not open and that they do not have an abnormal resistance reading. First, let's make sure the ohm meter and test leads are working properly. With the leads shorted together, we see the meter displays about 0.1 ohm. Looking at R45, I'm placing one probe on the emitter bus and the other probe on the opposite side of the resistor. We can see we have about 0.4 ohms. Subtracting about 0.1 ohm for the meter leads, That puts us close enough to .22 ohm resistor value. For this kind of low resistance measurement, that is good enough for me, especially if the other resistors read consistently. Moving on to R43, we have about 0.4 ohms. This one is good. Now R40. Again, we have about 4 ohms. This one is good. Now moving to bank 2 and checking R46, we have about 0.4 ohms. This resistor is good. Now R44, we have about 0.4 ohms. This one is good. Now R42. Again, we have about 0.4 ohms. This resistor is good. I also took a look at R41 on both channels. R41 is connected between the collectors of the driver transistor Q12 and the output transistor Q14. As the schematic shows, R41 is also 0.22 ohms, and it checked good on both channels. I have 20 PL909 output transistors, and we need to check them with the Peak Atlas DCA75 Pro. We will record the parameters so that we can match 3 output transistors per bank for a total of 12 output transistors on 4 banks. I numbered each transistor with a permanent marker on the bottom side so we can keep track of them during testing and matching. With the DCA75 Pro, you can connect it to a computer to record your results and save them. On the first transistor, we have a VBE of 0.505 volts and an HFE of 36. Now moving on to the next output transistor, on the second transistor, we have a VBE of 0.498 volts and an HFE of 23. You get the picture. We test all 20 outputs, record the readings, and then match the good transistor into banks of 3. Here are the results for the output transistor I marked number 20. As you can see, the DCA75 Pro does not identify it as a transistor. It shows open. This output transistor is bad. Here are the results for output transistor number 18. This one is interesting. The tester identifies it as a Zener diode, so this one is bad as well. I tested all 20 output transistors and recorded the parameters. As you can see here, my assistant Nova is pointing out the only 2 bad transistors, numbers 18 and 20. That leaves us with 18 good output transistors that we can match. Here, Nova is showing how we group them into match sets. Set A uses 2, 11, and 13. Set B uses outputs 4, 5, and 15. Set C uses outputs 3, 14, and 17. Set D uses outputs 6, 8, and 9. Look at the VBE matching percentages on the right. These range from 99.1% to 99.6%, which is excellent matching. I have arranged the output transistors into their respective groups. Now all I have to do is pick each one up and install it into the proper location. Here we go, placing the output transistors and securing them to the left channel of the amplifier. I am using silicon pads underneath the transistors. These pads transfer heat effectively while also insulating the collectors from the chassis. After installing them, I torque the screws by hand. Do not over-tighten them, just snug. It takes a feel, but I've been doing this since I was about 18 years old working on TV repair. Also, make sure the socket underneath is properly seated. The screw will not grab correctly if the socket or the transistor is not sitting completely flush. Now that the left channel is complete, we'll move over and install the output transistors on the right channel. That is it. We're done installing the output transistors. Now let's make sure we do not have any shorted collectors, meaning the output transistor cases are not shorted to chassis ground. This is important because on bank 1, output transistors Q13, Q15, and Q17 have their collectors tied to the positive rail. If one of those collectors is shorted to the chassis, the positive rail fuse will blow. On bank 2, output transistors Q14, Q16, and Q18 have their collectors connected to the output. If any of those are shorted to the chassis, it will cause serious issues beyond just a blown fuse. My negative meter probe is inserted into a hole on the power transformer, which should be grounded to the chassis. Let's verify chassis continuity by placing a positive probe on Q6. We should get a very low ohm reading. We are good. We have about a 0.5 ohm reading, so now we can proceed with the inspection. All of the output transistors in each bank have their collectors tied together on a bus bar. Placing a positive probe on that collector bus bar, we see an open reading. All these collectors on this bank are isolated from chassis ground and are fine. Now checking bank 2, even though these collectors are connected to the output, they are still tied together on a bus bar. Placing a positive probe on that bus bar, we have an open reading. All 3 collectors on bank 2 are fine. Checking banks 3 and 4 on the right channel of the amp, we get the same results. The collectors of all the output transistors are isolated from chassis ground. This amplifier did not come with any output transistors or driver transistors. In a phase linear 400 series 1, you cannot simply replace the original driver transistors with modern substitutes. The reason is that newer transistors generally have wider bandwidth, and in this amplifier, that can lead to parasitic oscillations. I did not have any of the original driver transistors, so I reached out on the Phoenix Audio forum and asked if anyone had any available. This is an excellent site with knowledgeable people who are willing to help. I received 2 responses, one from a friend I have known for many years and another from someone I never met. The person I did not know told my friend, "I've got this." He then sent me a private email and asked for my address. Before I could even ask how much he wanted for them, they were already in the mail. I wanted to share who this new friend is because this really reflects on the spirit of Phoenix Audio Forum. People who are friendly and willing to help others, whether they are new, learning, or experienced in asking deeper questions. These guys are awesome. His name is Lee Latch. A special thanks goes out to you, Lee. I will be calling you soon. Just like the output transistors, I numbered the driver transistors for reference. It is important to match these driver transistors for gain within each channel. Again, I will be using my Peak Atlas CCA75 Pro to obtain the measurements. 2 of these driver transistors did not fall within the range as the others, as you can see at the top of the graphic. However, we are able to select 2 well-matched driver transistors for each channel as shown at the bottom of the graphic. Let's go ahead and install the drivers. Beautiful, isn't it? By the way, the collectors of these driver transistors are tied to the same locations as the output transistors. I checked the drivers for shorts as well and found none. We are all good to go. There you have it. We performed the C6 modification. The output and driver transistors were matched and installed. We also took a look at that backplane, and it's looking good. Now, in the next episode, We're going to be replacing the power supply caps and the bridge rectifier. Along with that, we'll be installing the PL14 control board that we rebuilt on the last episode. We'll be wiring it in. Thank you for watching, and we'll see you on the next episode. It's a wrap.